Hello and welcome back. In this video we are going to test the worker thread system that we put together in the last video, basically by mimicking the functionality that was developed when we were discussing how worker threads actually work. So Lee, why don't you go ahead and roll with it?
All right. I got to figure out where I put my mouse. There it is.
There it is.
Yeah. Kind of lost it.
That's probably my fault, actually.
So here we go. Let's go over to the program. Now, I'm going to make a couple of modifications because we now have worker threads which are different classes. And I want to be able to access this exit thread that we're using as our exit command.
Mm-hmm.
And not the best practice here, but it's just temporary code just to prove that things work. So I'm going to make it a public static bool instead of a private.
Mm-hmm.
So I can, I'm trying to refactor it. So I can access it from any threads that we create.
Mm-hmm.
We can still leave this here. And then we have this functionality here. Now, I want to use this functionality that we put in the demonstration, but I want to use it using our new framework. So what we're going to do is we're going to create a whole new class. Hey, look, it's not grayed out. All right, so new class. This is going to be our test worker thread. Initial cleanup. Now our test worker thread is going to inherit from our base class, or our abstract class, our worker thread abstract class.
Mm-hmm.
So once we do that, we get the error again that says, hold on, we have to implement members because there are certain contracts that we have to enforce. The one that we have to implement is run, which is the one that we expect.
Yeah.
And this is where all of our base functionality is going to go into. Because this is such a simple example, we don't need to implement the stop. There's going to be nothing that we need to throw away. But if I did want to do that, I could go protected override, and then it's going to give me the methods that I can override, stop, and this gives me the ability to execute any cleanup code that I need to do. So if for some reason, let's say I were to do a private string, we'll call this message. And for some reason, we needed to make sure that message was set to null. So whenever the thread ended, we have to make sure that message needs to be sent to null.
Mm-hmm.
Don't know why we would need to do that, but in this case, let's just say we had to. So now that when stop was called, we know that message will be called based on the way that the abstract class is set up. Because when we call stop, this is going to be called, and technically it will be the base class, so the stop will get called, and then it'll call base.stop. But there's nothing in base.stop, so I could remove that, but there's no harm in calling it anyways.
Okay.
So either way is fine. Now inside of run, this is where all of our functionality needs to go. We already defined what the functionality was going to be, which is this. So I can take this code and go to our test worker thread, drop that code right in here,
Mm-hmm.
implement the threading. Now notice exit thread has given us an error. It's because I need to be able to get a hold of that. Oops. What one am I missing?
Well, the spelling's right.
Program. namespace, class, Unity threading. So I have to implement the Unity threading namespace here. And there. Now I'll be happy.
Gotcha.
So now I can
With the
pass
using
through
statement.
the exit through. Right. So that'll allow me to pass through there. So the functionality that we need inside of here should work. And to have fun with this, because I did put this string in there, let's go ahead and set up a constructor. Just for sake of argument, let's say when you create this thread, you need to send in parameters, you need to initialize some stuff, you need a constructor. So in this case, public test worker thread, we're going to pass in a string, a strine. This will be message. And we'll say this dot message equals message. And in this case, I'll remove this and I'll say write out the message. Now inside a program, I can get rid of this worker thread because we don't need it anymore. Don't need that method, which is going to give us an error here, which I expect. So I'm going to delete that. Now here, this is where it gets a little bit different. So new test worker thread. Our test worker thread has a constructor that takes a message. I'll copy in our message, I am the worker thread. And then to start it, we can call thread dot start. So, and this should work. And notice we're not using stop.
Mm-hmm.
So if I hit F5, here goes our worker thread. So
something.
it's working. Now, if I hit the space, sending exit, I am worker thread, exit command received, and I exit out, just like before. Now let's do something a little bit different. Right now we're using this exit thread.
Mm-hmm.
I don't want to use that anymore. I just wanted to kind of modify it slightly just for testing purposes to keep things similar.
Okay.
So we got rid of that. That's going to cause us an error because we no longer have an exit thread here.
Right.
But what I want to do is still keep this exit thread. I like exit thread.
Okay.
I got attached to it for some reason. So we're going to implement it again as a field, just like we did before, but we're going to set it up here inside of our worker thread.
Mm-hmm.
So same concept. But now we're going to force stop to actually do something. So we're going to go through here and say exit thread equals true. Go back to program. And then say thread dot stop. And I need to go back and make that public, I believe. Because I made it protected instead. Test here, protected, yeah, public. There we go. So public, which means I need to go to override worker thread, yeah, public. All right. That clears that up. So now what should happen is when we hit the key, we're going to send the exit command. Technically, all we're doing is we're telling the thread to stop.
Mm-hmm.
That's going to go to test worker thread. It's going to call stop, which is going to set exit thread to true. which is going to cause this evaluation to fail, which means the next time it runs through this iteration of loop, it should fail and exit out.
Okay.
And why am I going down there? Force a habit. It's like going, okay, no, I'm not trying to go to Unity. All right, so it's running. I hit it, sending the exit command received.
There you go.
So it's running. Now, basically what we've done is we've made our thread completely self-contained.
Yeah.
So now we've got all of the logic and stuff inside of this class.
Right.
The
So
only
we're able
thing
to
that
just call on start and stop.
Yep. All we need to do is initialize it, or set it up. We define it, and then initialize it. Call it start. Call it stop when we want. The abstract and the wrapper that we made handles all the fine details for us, and then all we have to do is define our functionality inside of run, and then put any cleanup code that we need inside of stop.
Okay.
That simple.
Awesome.
So, and don't need Unity threading anymore, so I can clean that up too. So that is all I wanted to cover in this video. We just want this. The whole point of this video was just to re-implement the worker thread demonstration that we did in the first video,
right,
using our new API, so we could demonstrate how all that worked. Now that we have all this code in place and we have our framework for dealing with worker threads, we've got the priority queue that we did in the last set of videos. We've got all of the groundwork laid to allow us to move on to the thread pool implementation, which is what we're going to be handling in the next set of videos.
Very cool. Well, then that will wrap things up for this video. Thanks a lot for watching.